Hello and welcome to Technically Speaking, where scientists and engineers come together to chat about a common interest, share knowledge, and satisfy some curiosity. I'm Laura, and this time I'm joined by Ellie to talk about how life evolved in something known as the Cambrian explosion and the animals that were around at the time. So, Ellie, you're a zoologist. There's an obvious connection to the animals there, so tell me about your interest.
Yeah, I think it's pretty exciting. The Cambrian explosion is one of those things that people think, oh, zoologists, it's all about the animals that live now. But to get to the animals that live now, you have to go way back in geological time. And the Cambrian explosion is where animals get the good stuff. They stop living in the marine environments and sort of just milling about, and they come onto land and they start developing all different characteristics. And that is really the start of where we get animals that lived 500 million years ago. Those are the ancient ancestral lines that now persist all the way into today.
Okay, so I remember vague things about this from my undergraduate degree, which involved earth science and looking at the rock records. And there were things like rocks essentially eat each other, so the rock record only goes back so far. So if the Earth is something like 4.5 billion years old, the rock record is only about 4 billion years, so there's a bit of a gap. But we're not looking quite that far back in time, are we?
No, our magic seeing eye does not quite go back 4.5 billion years. It only goes back, well, today it only goes back about 540 million years ish.
Oh, and is that when all this sort of stuff was taking off?
Yeah, so I think there's a little bit of discrepancy because obviously it was so long ago, but most people sort of agree that the Cambrian explosion was between 541 and 530 million years ago, at the beginning of the Cambrian period in geological time.
And I like the word explosion makes it sound really sudden, which I guess in geological timescales it probably is.
Yeah, so I think most people think of an explosion as like they've been watching Oppenheimer and it's one massive boom. But this is much more like comparatively. So, like, evolution takes millions of years, but in the timescale of all evolution, this was the period of the most rapid evolution in Earth's history. So all the evolutionizing happened a lot quicker in this period than it does then before or after.
And it was the idea that I think as well that you got this huge increase in biodiversity essentially. I think I browsed through a research paper that was in the period before that, there were some animals, but they look really weird compared to the ones today, which makes them difficult to classify. And they kept hammering this point that they were weird.
They are super weird. Basically, before the Cambrian explosion, everything was just sort of floating around in the sea. There was a microbial mat that like they fed on, sort of, but they were all very soft and so like not well preserved in the fossil record. We don't know largely lots of the stuff that was alive then because to be preserved, it helps if you have a hard shell or bones, and lots of this stuff was squishy, and squishy doesn't preserve well, unfortunately.
No, I was reading up on this. So it's technically the spaces within the bones that they get mineralized as groundwater flows through the rock, and they fill those spaces and leave mineral deposits behind. And as the organic matter decays away, that's what's left. It's the things in the gaps in the bones. It's a strange sentence. And I think the squishy things were only preserved in areas where there was iron sulfide, I think it said.
Oh, yeah. I mean, some do preserve. It's not necessarily the case that all squishy things are never preserved, but yeah, just you find a lot more things that had hard parts because they preserve
Yeah.
better.
And it does make me wonder a bit, well, what kind of squishy things were around that we just don't know about?
I mean, probably. I think weird. Like that's the Cambrian explosion. Like pre-Cambrian explosion, there were like many legs and like tentacly bits and floaty worm things. It's yeah, strange, suspicious creatures.
No. But then there was something that caused this huge increase in diversity. And I think a lot of the reference I saw said body plans that we recognize today. So I guess having like defined like two arms and two legs, or spider like thorax and many legs, that sort of thing. Is that right?
Yeah, I think so. I think it's sort of like most stuff is a tube, right? At a very basic level, you have an in and out. And then once you get past this Cambrian period, things get legs, things get vision, things get bigger, and then it becomes like they get the good stuff. They get cool things, adaptations to different niches, and they stop being quite so sort of squishy and flobbery.
No, but still squishy inside with an in and an out, I guess.
Yeah, still you still got you got to start with the tube. That's what we say, and then build upon that. And you know, things that lived in the sea were a tube that didn't move, and then you get tubes that are moving and floating, and then they come out of the sea, and then the tubes start chasing other tubes. There you go. That's the history of entire evolution in a nutshell.
So saith the zoologists, well, it's tubes, guys. And you mentioned that it's pretty much just what is preserved in the rock record. And I do vaguely remember some of this from my undergrad degree, but do you have any more information on how we know what happened and when?
So lots of very clever people that don't describe stuff as just tubes will look at these animals that have been preserved. And so you can see then what arose and how the phyla that survived became modern life. So it's kind of hotly debated about what happened and when and who was living when and all of this sort of thing. But grazing organisms were largely present before the Cambrian explosion. This is what sort of gets preserved. There were microbes all over the sea floor. It was extremely low oxygen environment. And then you can see in the record what is preserved then after that period is very different. There's quite a lot more that's preserved. And so then you get this big explosion that was the Cambrian explosion as it changed over these several million years.
Cool. And I think what I remember from my undergrad degree was it was like a combination of figuring out what else you know from the rock record that's nearby and doing things like I think it's radiometric dating. I think carbon dating is the one people are most aware of because you see it on TV, which is looking at different isotopes of carbon in a material. But that only works on things that were still living at the time. So if you've had a fossil where all the organic matter has then been replaced with minerals instead, all that carbon's gone, so you can't really tell. So you have to use something else, hence why you sort of look at things around you. And I think carbon dating is only good for sort of things that are less than 500,000 years old. So instead you can use the decay of natural uranium. It eventually decays to lead. So you can look at the ratios of uranium to lead in your material and use that to figure out how old it is.
That's cool. I never would have thought about that. But yeah, I suppose uranium decay is one of those things to like measure the life of something, isn't it?
Yeah, and it's a bit more sort of longer lived, but it's still a longer lived isotope, I should say, I think. She says, not remembering any of the radiation science she's done recently. But it's still not that straightforward. There are like other things taken into account, so it's like one tool in the paleontologist's toolkit for figuring things out, along with what else do we know, and a whole load of other things.
Yeah, it's also the context as well of like where it was found, what the rock type was like that it was found in, what things were found near it is often quite a good clue. Like you can get lots preserved in one area from a certain time. There's quite a lot of papers and examples of like the Burgess Shale is like a super common one where loads of things were preserved all from that one time period. And scientists go back there regularly and dig up more stuff and find more cool animals that lived millions of years ago.
So tell me more about these animals. What's the most interesting one in your opinion? Or do you not have one?
Ah, now.
I think I've asked you this before, actually, in a more modern context.
This is just mean now. I mean, everyone loves trilobites. I think you can't mention the Cambrian explosion without mentioning trilobites. They're cool. They preserve well. They change as well. So before the Cambrian explosion, they were quite soft. They were swimming around in the sea, doing their own thing. And then because of what happened with the changing environmental conditions and the explosion taking place over millions of years, they come out and they get harder and they get a bit more sort of, think like horseshoe crab like. And they get exoskeletons. And they think partly this is because of the change in oxygen. So pre-Cambrian explosion, there's not that much oxygen on Earth, essentially. So everything's living in the sea. It's a very low oxygen environment. And then this big change takes place where suddenly, well, not suddenly, several million years, but effectively suddenly, it's a much more oxygen rich environment, and the levels of CO2 and oxygen are sort of changing quite a lot. And they think that allowed organisms to begin to leave the water and develop different ways of doing things.
Okay, because I was under the impression that animals officially left the sea after the Cambrian explosion. But I guess it's open to debate as to what do you mean by that, because they were apparently going out, likely to be going out the water a little bit initially, and then going back in and sort of living on that margin. And at which point did they then just not turn back? I think seems a little bit contentious.
Yeah, it is contentious. And a lot of people think this, like, the Cambrian explosion wasn't like a single thing, like a single, it was on this day. It's like an evolutionary period. And because it's a time scale, it then like bleeds into different like time frames. So you couldn't say definitely, oh, it started exactly 541 million years ago and it ended 530 million years ago. But you could gauge based on what we've got in the fossil record that it was probably around these times, and that the Cambrian and the Acadian sort of bleed together, and some organisms pre-Cambrian explosion survived into what was then the Cambrian, and some didn't, and then some evolved because of what happened that weren't alive before. So yeah, it's very much fluid. It's not a one single thing happened on this day.
For things that lived in the sea that are mainly tubes. You said that the oxygen levels rose, and I read it was one research paper, I think, that said that was partly because there wasn't any free oxygen around on Earth initially, way back, though 4.5 billion years ago. And it was bacteria essentially that started to produce the oxygen, although some of it will have been produced by ultraviolet rays from the sun hitting the atmosphere and breaking oxygen molecules off gases. But also that there were a lot of rocks that weren't oxidized and they absorbed a lot of the oxygen, which didn't leave a lot in the atmosphere for anything to do anything particularly useful. And it was only once the rocks had become oxidized, which I think it sounds a little bit weird. And I don't know if it's more than one research paper that says this, but I guess it kind of makes sense that this sudden increase in oxygen content, sudden in geological terms, might tie in with something becoming fully saturated.
I think so. I think the idea is that oxygen levels sort of facilitated the production of collagen. So this is like you see in the trilobites, they get harder because that change in oxygen means that they can make these proteins that make hard structures in the body. So it sort of like all ties in to what you're saying, that more oxygen means like a change in the animals.
It's got me curious now about how collagen is made, but I feel like that's probably a different
I couldn't
episode.
tell you for sure.
No, because instinctively I would assume that they need the harder exoskeletons to emerge from the sea and not just turn into mush because they're not being supported by the water around them. But it makes more sense that that adaptation came before they left the sea.
Yes. I mean, things weren't really living in the deep sea. It's not like they were, 2 kilometers down. They were sort of in the shallows as it was anyway. So they wouldn't have had the sort of, how things get really weird when you go really deep in the sea. But then
Yeah.
they would have been like a bit more, they would have been shallower anyway, so they wouldn't have needed quite so much support, I suppose. Or maybe they would, I don't know. That's an interesting one.
It's the first place my mind went to. It's probably completely wrong, though. Just seems logical.
We've done a collagen episode, haven't we?
We did. I don't think we looked at specifically how it's made initially. Like what, I mean, most things have got oxygen in them.
Yeah, that's true.
And I can imagine there would probably been other factors rather than just all the rocks stopped absorbing the oxygen because, as I said, the rock record isn't complete and rocks eat each other. There must be more to that. And I remember from my undergrad degree looking at paleoclimatology. And this was 20 years ago, by the way. And it was sort of like, is climate change really happening because of what people are doing? Or is it just one of those things that's happening anyway? Because there are factors like orbital forcing, where the Earth's orbit isn't incredibly stable on geological timescales and it wobbles very slightly. So sometimes we're, on average, slightly further away from the sun than we were in the previous few million years. and that difference affects how hot it is.
I mean, climate change is happening.
Yes, we know that now. Yes, this is like 20 years ago when we were like, well, people could be having an effect, like human activity could be having more of an effect versus what's already happening, and we don't have all the data to tell this. Now we know. Science has moved on a lot in those 2 decades, but way back when people weren't doing stuff and it was just the bacteria, apparently, in the natural processes, things were probably a bit different. I think I read that the oxygen content varied quite a lot from anywhere between like 5% to 35% in the early part of Earth's history, whereas now it's pretty much 20%. I feel like I should know that. I should be more definitive when I say it.
I think there's always scope to learn new things. You have to know all the answers all the time.
No, it just seems like a really obvious one that I should know, but I'm a bit ill, so facts are not coming to my brain the way they should. I'm a bit under the weather.
I think also what's interesting as well is that there was sort of an ecosystem before what we call the Cambrian explosion period. But what happens as well is that, like you were saying, that the sun and the carbon in all the rocks, nutrients that eroded from the rocks were then washed into the ocean. So that could have also been part of it, providing that calcium and phosphorus to help build like skeletons and hard shells. So also around that time, like more niches were available for the animals to live in. So before they'd all sort of been in the same area, but once this happened, animals start burrowing like into the sediment of the bottom of the shallows, and then they're stirring up the seafloor and stirring up more nutrients. So this sort of helps a lot of things happen. If suddenly you've got all this availability of different things that you never had before, then you can exploit that, and animals will, adapt and evolve to exploit all these different things.
So I guess there are at least two things going on there. There are the chemical changes caused by changing climate or changing environmental conditions, the oxygen and the washing away of the nutrients into the sea from the land. And there was also a change in animal behaviour if they started to dig.
Yeah, absolutely. So there's also that, and then because of this, you start getting like the first more complex food webs and like predators. So before that, everyone was sort of, I guess, eating the same things or feeding on microbial life. But you get bite marks in the fossil record, and I think that's so cool. And like some fossils are so well preserved, you can see the gut contents, so you can see that they were eating each other, which I think is amazing.
Wow, you've got to wonder at that first animal that thought, oh, I wonder what'll happen if I just eat this thing sitting next to me.
Yeah, I think that's incredible. Like, how did they go from just sort of eating, I guess, algae and microorganisms and bacteria to then being like, no, I'm going to have a go at you and see if you're tasty.
Yeah, I guess there must be something in there about, like, if you think of like plankton and whatever else, it kind of floats around in the sea and it's just whatever happens, happens. But if you're a predator, you're sort of actively going out there and finding food at that point.
Yeah. So you can see how much more complex they got from like relatively simple organisms that were living in the sea and, not doing perhaps as much complex behavior. And then suddenly all these nutrients come in, animals are evolving in a different way, there's different niches to exploit, and suddenly all these complex relationships form between all the animals, and they're chasing each other and eating each other and, you know, being cooler. See, this is what I said. This is the Cambrian experience where you get the good stuff. Suddenly you get much more complex relationships, much more complex body plans, like the animals are changing themselves, and it all happens in a relatively short period of just several million years.
Relatively short. This was way before the dinosaurs. They were wiped out 65 million years ago. I don't know when dinosaurs were first considered to have been and when they were first seen in the rock record. It's probably more accurate to say.
That's true. When did dinosaurs like officially start? Because also there's a big period. Like people get confused because of stuff like Jurassic Park and all the rest of it. But like T-Rex and Triceratops didn't live at the same time. Like there's a big gap between them. And dinosaurs got wiped out 66 million years ago, but there was a long time before that where they were living and different species went extinct at different times. Like they all weren't suddenly wiped out in one go, sort of thing.
Yeah, I guess again it's about they were adapted for particular environmental conditions and then they changed. So they know their niche stopped existing. I can't work out if we need to define what we mean by niche because we both know what we mean.
Yeah, that's true. I just googled it because I was intrigued. Dinosaurs appeared in the Triassic period, sort of 250, 200 million years ago. So you can see again, they've got a long period. If they all get wiped out 66 million years ago, they were still alive. Well, not all of them, but you know what I mean, for a big period of time.
Yeah, far longer than humans have been recording this information. Definitely.
But yes, niche, I would say, or it's a good definition, like a specific habitat in which an animal lives and is evolved to exploit the resources within that habitat.
So I guess a good example, going back to what you were saying about when you get into the deep sea, things get weird. You'd have things near the surface that like sunlight and they like it being fairly warm with a particular nutrient oxygen composition.
Yeah. High level of oxygen, low level of pressure.
Yeah, and the further down you go, the deeper it gets, the darker it gets.
But then they've evolved to live in that area and do it well like that. They've evolved into that niche of being in the very deep sea, and then the other animals at the top are living in their niche at the top of the ocean.
Yeah, and the two are unlikely to meet, but I guess there'll be a bit of a crossover for those intermediate levels.
Yeah, also, the thing you have to remember is that animals don't read the textbooks. Like, I find this so funny. This comes back to me quite a lot because you can say, oh, I don't know, the Dumbo octopus lives between 2 kilometres and 7 kilometres deep in the ocean. And then someone will take one of those fancy, you know, underwater submersibles and they'll see a Dumbo octopus and it'll be only a kilometre in the ocean. You know, they're doing their own thing. It's just like observation, isn't it? That's how we learn.
Yeah, so true. It's like every time I try and identify like birds in the garden, it used to be, and you'd look at idealized sketch on the RSPB website of what one's meant to look like with these very perfect colorings, and you go, I don't think it's that, but I don't know what else it is because there's natural variation, so the textbook can't encompass it all.
You're looking at it and you're like, is it a dirty robin or is it something else entirely? Yeah, there's a blackbird round here actually that's like brown and black, and I keep looking at it and going, it's definitely a blackbird, but it looks so weird. But it's probably just, you know, mutated or it's got one of those colour morphs or something like that. But yeah, it's definitely,
Yeah,
I'm convinced it's a blackbird. It just looks the wrong colours.
but it moves and acts and has the same shape as a blackbird, so it must be like 9 markers out of 10 say it's a blackbird.
Exactly. Speaking of birds and dinosaurs, I think what's quite funny is that dinosaurs basically evolve into birds. Like, that's what we have left. Like, dinosaurs become birds. And then if you go all the way back to the Cambrian explosion, like the first chordates, the first animals that will eventually become humans, evolve during this period. And so do loads of other relatives. So crabs, relatives of crustaceans, they all started to evolve. Starfish, sponges, worms. These are all like animals that were preserved in the fossil record, all these early ancestors, and then persisted and changed and evolved. But because of what happened then is why we get these crustaceans and starfish and mollusks and everything else from the Cambrian period, and us, which I think is really cool.
Ah. Have worms really evolved all that much if everything was just a tube before the Cambrian explosion?
There's quite a lot of worms, and also you get parasitic worms, which I think is slightly different. So I think worms get perhaps not as much. You know, trilobites are funky, but trilobites went extinct. Like, everyone loves a trilobite, but worms are still going.
Yeah. What's the difference then? What is there anything specific that killed off the trilobites in the end? Because I seem to remember them having quite a few like different. There were different classifications of trilobite. Not all trilobites are equal. Like same with I did a project in my undergrad on ammonites. You had to classify different swirly shells, which was quite difficult. Yeah, when you look at it. So they're kind of like, you know, spirally shells and they add to their shells in segments. So you had to look at the shape of each join and try and figure out, does that shape look like the same shape from this one? So is that the same ammonite when you're taking, again, like these 10 identifying points or whatever they are into account? Surprisingly hard. So what killed off the different types of trilobites?
The trilobites died out at the end of the Permian. So 251 million years ago. So they were alive for a pretty chunky period of Earth's history. But they were wiped out by the Permian mass extinction event. I mean, to be fair, everything was wiped out by that. That was like 90% of all species on Earth were killed by that event.
And was it like a huge environmental change? It's not like that, it can't all be asteroids, right? That was just the one event that probably most likely killed the dinosaurs.
Yeah.
Because there have been things like ice ages, haven't they? And again, the extinction event, it's not sudden.
No, exactly. There's a thing that happens, and then there's a long period of time of fallout of because of that thing.
So is there any agreement on the end of that era or period in geological time?
Sort of the end of, well, I suppose the end of the Cambrian then continues for quite a long time, and then you get the Ordovician, which I can never say.
Oh, I always say it's Ordovician, but I don't know why.
And then you get more corals, and you get funky things like nautiloids. But then also stuff still dies off, right? So the world doesn't stop changing after the Cambrian explosion. There's still lots of environmental changes, there's still lots of things happening, but not quite as fast as during the Cambrian. But yeah, afterwards, in the Ordovician, I've learnt it now, lots of marine species die off. And then you get the Silurian, and then you carry on and carry on until you get to the dinosaurs and eventually modern day animal.
So at some point during all this, animals, although they might have been emerging from the sea occasionally, were finally like, right, that is it. We are definitely on land now. There might have only been bacteria before us, but now there are animals, and presumably before that there were plants. I read one research study that they were really interested in how eyes had evolved and why they'd gotten bigger.
Yeah, so this is part of the Cambrian, is like suddenly stuff gets really good eyesight.
Yeah, and they reckon part of it was like they started to see food on land and thought, oh look, there's more stuff over there and no one else is eating it.
Yeah, I guess that's part of it. Like compound eyes become a thing during the Cambrian explosion. Yeah, so maybe they were literally like, hang on a second, if we can see it, then we can eat it.
Yeah, and apparently that was the main impetus for leaving the seas. As you say, there were more niches available, and this niche was not yet filled.
Yeah, and also think of the like selection advantage. Like if you can see, but the animals around you can't, surely you're going to be better adapted to the situation, to the conditions, to avoiding these predators that are coming in, and yeah, therefore be more likely to survive. Which is perhaps why like compound eyes now are quite prevalent.
You can imagine though, so like the food webs that we currently have today, there's an apex predator, and their population is sort of controlled by the amount of food that they have.
Yeah.
But back then, if there was nothing else, it's just you and all these plants.
I don't know about plants. I can't say for certain one way or the other when the plants came, what the plants were doing. I've no idea. I'll be totally honest.
I'm sure I'd read it was before animals definitely were deemed to have left the seas permanently. But I don't have my notes in front of me to back that up because I was focusing more on the animal side of it. It must have been in this huge state of flux, right? The food webs are usually fairly balanced, the ones that we see today, unless humans have interfered somehow. So there's enough food to sustain that predator. If there are too many predators, something has to give in that top part of the food chain. But back then, if you don't have that, like how easy would it have been for these animals to sort of go nuts, wipe out most of the plant life?
Just have like a massive all-you-can-eat buffet on all the plants that were around.
And then they've suddenly done themselves in because there's no more food left and they can't get more food. I don't think that would ever have happened. I think evolution would have been a bit slower than that.
I would have thought so.
It's difficult to know. I don't really know what was around at the time, and the rock record isn't necessarily a complete picture, is it?
No, absolutely not, yeah.
No, and I can't imagine any scientist would ever publish a research paper saying, well, I think this happened, but I don't have a shred of evidence.
Yeah, I think you might get called out at some point when you try and pass that through peer review.
No, but I can imagine a lot of paleontologists sit around saying, oh, well, maybe, what about this? Let's throw some ideas around. It could lead somewhere.
Yeah. Well, the thing is, we don't know, right? We can't go back 500 million years ago and find out when the plants came or what was happening or why this happened for certain. We can only make inferences based on what we've got, what's in the fossil record, what survived. So, yeah, we could be missing a huge piece of the puzzle. And we could never know. You know, we only get further away from what happened. But then I guess techniques, like you were talking about earlier, how we know the fossils are however old they are, those things change. The technology changes to allow us to look back in time maybe a bit more easily. But yeah, I guess you can never know or say for certain why this one thing happened versus another thing. But I'm sure lots of people have a better idea when the plants came, because I have zero idea.
I think it's something we can probably look up for a future episode. It's just not something I focused on when I was researching for this episode.
No, I think the Cambrian explosion deserves to be about the animals. And we'll focus on the plants. We'll give their plants the due attention when the time comes.
Is there anything else that you know about the Cambrian explosion that we've not really talked about? It's worth mentioning.
Ooh, that's a good question. I think there's more to it than people realise. I think it wasn't just 5 things living in the ocean that then decided that they were going to become hard and live on land. Like, there was a lot going on, and then it changed very rapidly because of all the environmental conditions and all the things we've made. And then it became life on Earth, like, that we know of. We can trace stuff back 500 and however many million years to stuff that survives. And I think that's the cool part of it. And I think, well, people say that the Cambrian explosion is like the most significant evolutionary event in Earth's history. And yeah, but then a lot of stuff came after. And I'm sure lots of people argue that other things were more important. But I like the Cambrian explosion.
But you know what you were saying about there is stuff that probably isn't preserved that we don't know about. It makes me wonder, going on with my weird animals rampaging and eating all the plants theme, like what may have existed that we have no way of knowing about.
Oh, that's fun. I mean, even the stuff that did exist that we know about is pretty funky. So you can only imagine it was even weirder. The classic Cambrian explosion picture that I have in my head is one of those. I don't know if you've ever seen a picture. Oh, they're called like something. These animalocardus, and it's sort of like a fan with a long body and then sticky out eyes. They look very peculiar, but they really lived. Like, we know that happened, but then there must have been so much other funky stuff that was much more like soft and flubbery and maybe more squiddy things, but then squids are quite complex, so they probably don't come into it until much later.
A simple squid.
Simple squid, yeah, something like that.
A simple squid that's just what? Do squids have brains, or is that something
Yeah.
else I'm thinking of? I thought so. Something appeared on my newsfeed.
Jellyfish.
It might have been, yes. And then it ended with we're doing this so we can figure out how to put like brains on chips or something like that. And I don't know any more than that, but it sounds like an intriguing future episode.
Absolutely. Yeah, I want to know where you're going with that.
No, random tangent. It's quite difficult to try and imagine stuff when there's all this like diversity of life out here already.
Yeah, and then like think of something that might have existed a long time ago.
Yeah. But see, I wonder if there might have been something in the atmosphere that obviously can't be preserved in the rock record that was actually quite large, like not bacteria,
Oh.
that was like floating around up there, somehow absorbing stuff out of the atmosphere, which I'm assuming would have had a lot of CO2 and possibly some other carbon containing gases.
I would have thought so.
And sulfur from volcanoes.
I'm imagining like flying carpet sort of shape, but like really thin and like sort of like a manta ray, but not as cool. Like just good at absorbing things.
Or wafer thin, like almost transparent.
Yeah.
Like ghosts.
With no eyes. Or like really simple eye structures.
Yeah, or because they're floating around in the atmosphere, they're essentially balloon animals.
Oh my goodness me.
You never know. I think before the Cambrian explosion, one of the biggest, oldest animals is essentially this like floppy bath mat is described as. It was in the sea, not in the sky.
Yeah, these like microbial mat things get mentioned. I think people aren't really sure what they were. Like, it's very hard to know. Like, the definitions haven't been developed. Like, we only started naming stuff once we evolved and then, you know, get to Darwin and all the rest of it and Linnaeus. So all the stuff that lived before, we don't necessarily have the categories or the evolutionary trees to know what it was or like where to put it. So yeah, it could have been literally anything.
No, the floppy bath mat of the sea, whatever its official name is. Maybe it's got a counterpart in the sky.
I mean, it takes a long time for wings to develop, so.
But it's light enough, it just kind of floats around.
Like a jellyfish, but of the air.
Yeah, it's like spiders can travel using sort of electrostatic currents in the air. So when they make their parachutey web things, they're not catching a breeze, they're catching electrostatic interactions. So maybe there's a floaty bath mat thing that was doing that way back when.
I hope so. I hope so.
I feel like we're just we are literally making things up now. So
Probably time to call it a day.
having stopped doing the science, yeah. So you're essentially saying like we can trace our ancestry back to around about 5.5 million years ago when things started to take off in the biodiversity world. And we probably owe a lot to those changing conditions, and that there are animals that have somehow survived despite all of these changing conditions since then that we can still recognise in that quite ancient rock record.
Yeah, absolutely.
Cool. And there are lots of funky sounding pictures that you can probably look up, and I guess we'll share on social media.
Oh, yeah, absolutely Google Cambrian explosion animals, because that is a wild ride.
Oh, there you go. Something to do on a rainy Sunday afternoon. And I guess we'll pick up some of the stuff like paleobotany. Is that a thing?
Oh, absolutely. I'm sure it's a thing. Yeah, if people want to know about when plants got good, that can be a future episode.
Yeah, there you go. Let us know if you'd like to hear that. And stay tuned, see what happens next. We'll see you then. The views expressed in this podcast belong entirely to the person that said them. They do not represent any industry or organisation. If you enjoyed listening to these views, it would really help us out if you could rate us, leave a review and tell a friend. This podcast was sponsored by no one, but if you're interested in funding us to continue to have frank discussions about science and engineering, please get in touch.